Just a second. Okay. So in this work, we were trying to understand about the self-organizing behavior of the vehicles. But before going into the details, let's try to understand what is self-organizing. So self-organizing is a naturally observed behavior where we have got something structural and stable patterns are observed in the processes, like flocking of the birds, like robots coordinating with each other. So whenever we observe such kind of behavior, like we have got something which is structured, there are patterns observed, so that thing is called as self-organizing. This similar kind of behavior has been observed in the vehicles also, where we observe the vehicle platooning, we observe the vehicles moving in the waves. So the basic principle of the self-organizing is that some pattern is there which is stable and nothing is controlled centrally. So the similar kind of behavior has been observed in the vehicles, but there aren't metrics yet to quantify the same thing. Besides, there have been some attempts done in the past which have tried to understand this behavior using the traffic performance index. Some people have also used the coefficient of variation to explain this. However, the metrics are not able to have the structural alignment and the spacing stabilities. Those things were not being able to covered by those existing metrics. So to address that thing, this study is proposing a metric which is self-organizing road traffic index, and that metric is actually focusing on understanding how the vehicles self-organize. Along with that, we are trying to maintain the structural alignment as well as the spacing stabilities. So basically in this metric, we are trying to measure the self-organizing with respect to the ideal and local conditions. So what exactly the SORT index does, we'll go into the details in the coming slides. Let's first take a look at the data which we have used for this particular study. So in this study, we have focusing on both primary data as well as the secondary data. For the primary data, we have collected the data in Delhi. We have used a data set of India as well as China, US, and Europe also. So some of the data sets were collected by us. Some were obtained from the studies which have been already published. So we wanted to understand this behavior globally, and we wanted to check is there self-organizing from different traffic regimes. So taking a look at the descriptive stats, so I'll be focusing only on speed and minimum intervehicular distance, because in this study we have only focused on these two. And we can see that there is a considerable difference in the speeds for traffic flows, which also sort of justifies the use of different data sources so that we can observe the behavior globally. Now, coming to the methodology which will help us to understand how and we were able to quantify the self-organizing behavior. So first we had the trajectory data. What we tried to do is we tried to label each vehicle. Each unique vehicle was labeled as subject vehicle, and then we tried to check how many vehicles are in proximity to that vehicle, which is the proximity for each video frame. And if there is any vehicle in the proximity, we then moved ahead and we tried to understand the interactions of that vehicle with the other vehicles. So in this particular study, we only were focused on the rear-end interactions. We just determined the leader-follower pairs so that we can determine the minimum intervehicular distances at that particular speed, so that we can understand the self-organization of that traffic regime. So what exactly we did was, so here on this scatter plot, we are looking at the speed of the subject vehicle and the minimum intervehicular distances. So this particular plot will help us to understand how the vehicles are self-organizing. So here we can see that at the minimum speeds or at the lower speeds as well as at the higher speeds, the vehicles tend to have kind of similar intervehicular distances. So what we tried to do in this particular paper was that we tried to fit a line to understand how this particular line is deviated from the ideal conditions. What are the ideal conditions? I'll show that in the coming slides. So here we can see that in the upper speed, lower speed regions as well as the higher speed regions, the vehicles tend to behave similar. Along with that, there is an optimal speed range wherein vehicles tend to have minimum intervehicular distances. So this whole thing let us start the process of determining the self-organizing in the vehicle regimes. So we try to do the similar thing with all the data sets which we have, and taking a look at these graphs, we can see that there is some kind of similar behavior which has been shown by these vehicle trajectories all over the world. So coming to the observations which we had already discussed, the vehicles tend to behave similar in the higher speed regions and the lower speed regions, and we have got an optimal speed range where vehicles tend to have minimum intervehicular distances, and we try to quantify this particular behavior using an index called as SOT. Now, how the SOT formulation has been done. So initially what we tried to do is we tried to find a reference curve. So since it is a very chaotic behavior which we want to quantify mathematically, for that, what we did is the first step was we selected a reference. So for this study, we have used two references, a local reference as well as the global reference. So if you talk about the local reference, in the local reference, we assume that, which is an ideal reference, we assume that at 40 km/h, the vehicles tend to have no spacing with respect to each other. And we tried to understand how much the real curve is deviated from that local curve. And we tried to do the same thing with our local reference. We use the mean of the spacings to determine the local reference to understand this behavior. And now we go to the formula which we use for this SOT index. So we simply try to understand how the fitted curve is deviated from the ideal curve. And along with that, we added another term for the stability, which is simply coefficient of variation of the speeds to understand how is the spread for a particular speed range, how the intervehicular distance is varying, so that we will be able to quantify the self-organizing with respect either locally or either with the ideal conditions or with the local reference conditions. The local reference condition is based on the data sets which we have, so that we can have a number to that particular regime and we can comment on it as self-organizing behavior. So this particular study was just to formulate some formula to understand the self-organizing for different for different traffic conditions all over the world, and we are trying to expand the work using more data sets, using additional metrics in order to understand this behavior in a proper manner. Besides that, till this point, we have found that this self-organizing behavior is there in different parts of the world, because we looked at the graphs, we observed the similar kind of the behaviors, and the methodology can be used to quantify the self-organizing if you have got the microscopic trajectory data. Thank you. Any questions?
Yeah. Hello. So good morning. I got late a bit.
Good morning, sir.
Any questions from the audience? Any comments? Shalini? I'll come in the end. I scribbled few things.
Okay.
Wanted to understand your paper. Good work.
Thank you.
Thank you. Thank you for the presentation, Mehrab. Very extensive work seems to have been done. Two questions in terms of the international data sources, if you could clarify where you have got the detailed traffic, information, microscopic information.
Okay.
And the second question is more in terms of the applicability to the real world conditions. What is the policy implication of your study for our Indian cities, if you can highlight that? Thank you.
So for the Indian conditions, for Delhi, we have collected the data ourselves using the drone. And for the other countries which I mentioned, like US, China, so it is open source. We can access it online. So there are some universities where students have worked on the trajectories, and after that they have uploaded the data on their respective university websites, wherefrom we can access the data. And regarding the policy implications, so this particular piece of work was just focused to quantify the self-organization using any mathematical measure. We tried many iterations, and finally we reached to this integral formula. we are planning to expand the work using other metrics, other traffic metrics also. Like for now, we are only using speed and minimum intervehicular distances, but it can find applications in signal designing, optimizing the signals. But right now, it is too soon to comment on it because we are still trying to understand and quantify the self-organization.
Mayoral, nice work. I was just trying to understand this whole idea of self-organizing and which you're trying to quantify. Mainly you have used inter-vehicle distance as a way to quantify and understand it. But isn't that natural that self-organizing is anyway always there in the traffic stream? It will never happen that vehicles will just behave random and, have varying level of distances and other things kept. The natural, phenomena that you gave as an example at the beginning essentially happens when there is some kind of group behavior, where it makes a lot more sense to think about and talk about self-organizing behavior. Likewise, in crowd events, for example, we have done extensive work on Kumbh Mela. People come in social groups, and there you see a self-organizing behavior among those groups. So I'm not able to understand why we are even talking about doing this for vehicular traffic, because in any case, vehicles will try to vary their inter-vehicle distance based on the speed at which the stream is moving. So I'm still not clear about the motivation of why we are doing this.
Okay, so like you clearly mentioned, yes, we are observing self-organizing in different phenomena, like especially in the crowds, the social distancing thing. The similar kind of things has been already observed in the traffic regimes itself. But we were trying to quantify this. We were trying to label it as a number, so that it might.
How does it help? I mean, you said that we can apply it for traffic signal optimization. Can you give me an idea using this index? What is that I can do? The other aspect is the safety.
Yes.
You may comment on the efficiency and the throughput, how much it is increasing with self-organizing. But what is the safety angle? Have you thought about?
Like you said, so the thing is, just a second, I'll just go back to the graph. Any of the graphs we can look at. Like, so, like ma'am asked, so still our first step was to give it a number, like to quantify it. Now coming back to the important step, which is applications, where exactly we are trying to apply it. So it can find its application in the safety, because majority of the times we focus our corridors to be high speed so that they can be cleared in less amount of time, so that we can save time. But if you look at these graphs, we can see that the capacity, minimum intervehicular distances, at the higher speeds as well as the lower speeds, we are observing kind of a similar behavior. So it is not always true that if I am going to design some intersection or a corridor high speed, it's going to increase my efficiency. We can have our efficiencies at the lower speeds itself, like the optimal, near that dip. So if we try to focus the design of our roads near to this point, we can have our efficiencies, like we can then trade off between the efficiency and
these
safety.
distances, have you observed longitudinally or laterally also?
So only the rear-end interactions.
Rear-end.
Besides, in the Indian context, we have got the lateral distances, which are also important. But since we were trying to compare it with the global data set like US,
I
China,
know, but then with the mixed traffic conditions that we have
Yes.
and the 2D motion. So again, so you have to think a lot. And can you just switch to the subsequent slide where you have that comparison with the ideal curve? Go further, next. Yeah, here your ideal reference curve is touching 0 at 40
Yes.
kmph. Why is it so?
so the ideal is not practical in this case. So,
But it can, even in ideal, it cannot be 0, no?
yes, it can never practically, it can never be 0. So this was just to sort of get a reference to reach that particular number. But then, like we had that thing in mind, it is not practically true. We shifted to the local, we can look at another curve. We shifted to the local reference. Okay.
I think I'll just briefly, I think interesting work. Obviously, I will just echo my colleagues, thing that we need to also look into the practical dimensions of a research problem. Research is not for just doing a research, please. Yes. You are a good researcher, but always look into the practical aspect. It's very important. I was just wondering, your paper probably didn't mention, or in these slides also in the paper, the site attributes in terms of road type, lane configuration, urban, interurban, abutting land use, all this will affect your traffic stream, behavior, speed. So probably I didn't find it very explicitly mentioned, neither in the paper, nor probably here. Because when you were doing a cross-sectional comparison between case sites, I think the first thing is, what are the site attributes? Are they comparable, not comparable? Are you getting it?
I got your point.
So
So
this
that
probably
referencing is not there, like you are saying. If
it
you
was
have
not. It was not very clear. I think that is very important. Whenever we're doing a case study, I'm sure you are aware of it.
I got your point. So what the thing is, we cannot directly compare, say for example, US with India. We cannot directly compare that thing.
So something contextual probably becomes very important. And one more thing is, you said alpha equal to beta 0.5. Now, suppose if your model is ready, you can always have various values of alpha beta combination, and you could have presented that also, to see how the curve shifts from the reference curve. Obviously. I think that also could have been added. These are two small points which I would like to just add. Okay?
So I completely agree with your observations. So that's the reason we only considered the rear end interactions, because we had already that thing back in the mind. We are talking about heterogeneous conditions in India. We cannot compare directly that thing with the US-based conditions. That is the answer to that referencing. And like you said, practical implications of a work should be there. So till this point, this self-organizing behavior is, we can say, unexplored. But now when we start talking about it in terms of numbers, then only we can start a discussion, like where we can use it, why we should care about it. But first, the important thing was to quantify it by some manner. We can change the method. We are planning to use the chaos theory actually to quantify this. We are in the process of that, like how we can use the chaos theory to quantify this particular behavior. There are some iterations done, but since for this particular conference, we were just focusing on, say, sort of starting the discussion on this and how it can find applications, like Professor Verma said, in the safety perspective or in the crowd management itself. So we can develop some methodology so that we can understand how the vehicles or people are organizing, so that then we can talk about the applications.
I mean, we all get the point. I think last point, I just want to carry to Professor Verma's point. I think a conceptual framework, if you would have ended with that how it is useful. For example, traffic signal optimization.
Yes.
I think you should come out with a flow chart. What is the current practice and how the state of practice can be improved by your methodology? You don't have to answer, but I thought this is how, it generates more interest.
No, I got your point. We are definitely going to do that, but once we are sure that we have been able to quantify it, we are still unsure that the metric is able to do justice to the self-organizing.
Okay. Thank you. Thank you.
Any other questions from the audience?
No, I think.
Okay, thank you so much.
Okay, now I will now request Dilsha Dilip. Yeah. She is going to make a presentation on the topic spatial optimization of humanitarian logistics during flood. So please respect the time allotted, okay? Yeah.
Good morning. My name is Dilsha Dilip, and my topic is spatial optimization of humanitarian logistics during flood, identification of parameters. From the global statistics itself, it's very clear that the global number of reported disasters and the annual number of people requiring immediate assistance during disasters are increasing. So getting aid to the disaster-affected areas quickly is a major issue that I'm focusing on my research. And for that, This research will solve the problem by identifying the parameters for spatial optimization of humanitarian logistics for developing a spatial optimization model. The aim of the research is to identify the parameters for spatial optimization of humanitarian logistics during flood. And the objectives are study of various scenarios, existing optimization models, solutions for the spatial optimization of humanitarian logistics. And next, the objective is to identify the scenario and then refinement of parameters. And the final set of prioritized parameters is obtained. For that, first, for the methodology, the literature review was done, and the concepts of humanitarian logistics, humanitarian supply chain, intervention phases, etc. was studied, and then the scenario was identified for the type of intervention, type of problem, type of model, and disaster was identified, and then parameters were identified, which was classified into geospatial, disaster-specific operational demand supply, and for the refinement and prioritization, Delphi method were used. And the scope involves how government agencies respond to manage the humanitarian logistics, and it doesn't include other multi-modal transportation, only based on land-based model, and it only focuses on the last mile delivery operations. And this is search methodology for the literature review. Out of 109 research papers, the literature review was done. And from the literature review inferences, background study, and the research gap and scenario was identified. So what is humanitarian logistics? It can be simply defined as a branch of logistics that deals with the logistical aspects of disaster management system. It differs from the commercial supply chain as the final persons are not the customers, it is the beneficiaries, and the key stakeholders involved are government, military, donors, NGOs, etc. While looking into the keyword of co-occurrence network system, an important term was humanitarian supply chain. And the difference of humanitarian supply chain, the stages were identified, and the research was most focused into the transportation stage. For the management of transportation, different optimization models were identified, and based on there were two types of models based on mathematical analysis and based on biological intelligence. And as a planner, I was focused upon the spatial optimization model. It was also found out from different research papers that in the existing situation, integration of spatial models are lacking, and also it might help to address the real-world changes more efficiently. So what is spatial optimization? It is a concern with maximizing or minimizing an objective related to a problem of geographic nature. It is also already used in land use and urban planning, etc. Next was to identify the scenario, and for that, different phases of intervention was studied. And then, while looking into the relevance of humanitarian logistics in disaster management system, response phase in which the relief centers, installation of relief centers as well as delivery of relief goods were focused. And there were three major problems. One is location allocation problem of relief centers. Second is the vehicle routing problem. And third is the location routing problem, which is the integrated problem for location allocation as well as vehicle routing. Next was to identify the disaster. For that, a cross-analysis of classification of risks related to city logistics and classification of disaster based on cause was cross-analyzed, and a disaster with both, which is both naturally and anthropogenically happening, as well as with have complexity, uncertainty, ambiguity, and flood was finally selected. So the final identified scenario was to do the research for the spatial optimization in the response phase for the location routing problem during flood. And based on different case study analysis, a basic framework for spatial optimization was done, formulated. And first just to data preparation, And next is to do the spatial analysis and integrate the logistic model into it. And by using solution algorithms, it has to be spatially visualized, and the scenario testing has to be done, and sensitivity analysis has to be done. The final outputs will be mapped facility location optimized routes, heat maps of flood severity, aid demand, and graphs showing cost and time savings from optimization. So for parameter identification, a set of parameters were identified from the existing models, and the identified parameters were categorized into one for spatial analysis and another for the logistic model. I'm focusing on the spatial analysis parameters in this research paper, and it is geospatial as well as disaster specific. And for the prioritization, Delphi method was used. These are the criteria for selection of experts, and there were totally 15 experts validated the parameters, and gaps were identified. Extra parameters were added into the study, and 3 iterations were done. And for the analysis of the Delphi data, F-test was done, and final 21 parameters were subjected into F-test. And for prioritization of parameters, both F-test scores and average weight scores were compared, and parameters were ranked based on that. These are the final results in which F-test and average weight index was done, and ranking is given. These are the high priority parameters. These are specifically the spatial parameters for the spatial analysis: location of distribution center, travel time between distribution center and disaster site, etc. And these are the medium priority parameters, and final low priority parameters. And the final conclusion of this research is that it can be used for the improvement of last mile delivery logistics. The spatial models can be integrated for the real-time problem solving. And the future research directions are the spatial optimization model has to be developed, and it has to be integrated in the real time, and it has to be tested through simulations, validated with stakeholders, and multimodal transportation can also be integrated. It can also be adapted to different other disasters. Thank you.
Okay, thank you. Any questions, please, from the audience? If no, then my colleagues, any?
Thanks, Dilsha, for interesting work, and of course an important, relevant work in the context of Kerala also, because it faces flooding all the time. I found your paper a bit more theoretical.
Sorry, sir?
I found your paper a bit more theoretical than, understanding the actual real-world parameters and implications. You have tried to think about putting together parameters that would make sense for the logistics. First of all, you gave a review with respect to different kinds of disasters, but your title said that you're focusing on flood.
Yeah.
So it was a little confusing for me whether you're focusing on flood or on different kinds of disasters. The other thing is, where is the vulnerability analysis of the network? When flooding happens, and you're taking parameters of travel time between, distribution center and, sites where the logistics has to go. Where is the network availability, the change in travel time due to flooding, and other vulnerability, analysis? Where does that come in picture?
In the spatial analysis itself, it has to be incorporated. The research is still going on, and in case of vulnerability, the different in case of developing the model, flood vulnerability maps will also be developed, and then in that only the logistic model will be integrated.
So currently you have not done?
No, I haven't done.
It's still a work in progress.
Yeah, it's still working on.
Yeah, thank you.
Yeah, that is what my comment was. Even if we assume that it is still work in progress, because it is not a case study driven, exercise. You're largely trying to identify through Delphi what are the various parameters which need to be given as a priority, and then you've conceptualized, how this logistics can be arranged.
Yeah.
Now, I was wondering that as an end to your work, probably two things you could have done. How the parameters identified in your study are similar or dissimilar to other reported works as a researcher. I mean, you've done a Delphi survey, you identified parameters. I'm sure somebody else across the globe would have also done similar kind of work. Are conditions contextual to Indian scenario, because obviously the experts belong to India. So how do they vary? I think that probably could have been added as a value addition. Okay. And what methods? The second point is, as a researcher, you've used Delphi. Are there other methods by which you can get priority weights or priority? I think these two things, if you could have added, it would have been more, it would have strengthened your presentation. That is my brief comment here.
Yeah,
okay?
we can use different MCDM methods or etc. Yes. But for this research, I had time constraint, and also I didn't have enough samples for that, samples to do the MCDM. So that's why I chose Delphi method. For future research, very extensive methods can be used. This is just a start point.
So you're doing a PhD? You're a doctoral
I'm
scholar?
planning. I'm planning to do a PhD on that.
Planning? So planning
I've completed
a master's.
Masters right now.
So this is emanating out of your PhD topic, or this is a master's extension work?
This is a master's work.
Master's.
I might extend it to my PhD work also.
Okay. Thank you. Thank you.
Thank you, sir. Thank you, ma'am.
May I now request the next speaker, Abhirami Krishna Ashok. Yeah, please come. She is going to make a presentation on a unified framework for traffic state prediction and class-wise speed estimation in mixed traffic conditions. Okay, Abhirami, you can start, and please respect the time. Okay, thank you. Yeah.
Good morning, everyone. In the era of data-driven mobility, it's not the data alone, it's the insights from the data that shape how we plan and manage transport system. I am Abhirami Krishna Ashok from IIT Madras. I will be presenting a work on unified framework for traffic state prediction and class-wise speed estimation in mixed traffic conditions, aligning with the present theme of strategic mobility planning. Traffic state represents the traffic conditions on the road. In homogeneous traffic condition, when all vehicles are same, traffic state is defined as a function of stream speed. But whereas in mixed traffic conditions, different vehicle classes will behave differently due to varied static and kinematic features, and also due to lane-free movement. So therefore, for mixed traffic condition, traffic state is not a function of aggregated stream variable, it is a function of vehicle class-wise speeds. So therefore, traditional state variables such as speed, flow, density cannot capture this mixed traffic dynamics, and hence there is a need for a characterization framework based on class-wise speeds and a prediction that captures this mixed traffic behavior. So in this regard, in this paper I have used the characterization framework developed by us in our earlier work, where the traffic states are defined as a function of class-wise speeds, considering different vehicle classes. The optimal bin size was identified based on elbow method, varying the bin size from 4 to 10, and optimal was found out to be 6. Based on this characterization framework, we proceeded for the observed speed patterns. So theoretically, considering the three key vehicle classes observed in Indian condition, two-wheeler, three-wheeler and cars, 138 theoretical patterns comes out of this states defined. So hence there is a need for a data-driven methodology to figure out the most prevalent patterns out of it. And we can we have observed inter and intra-class behaviors within and across different traffic states, and hence we proceeded with the pattern analysis to identify the most prevalent patterns and the less frequent patterns. The most prevalent patterns are called predominant patterns and less frequent are called non-predominant patterns in the study. For this, data from 3 Indian cities, Chennai, Surat and Guwahati have been used, and based on how the relative likelihood of 3 vehicle classes across the 12 speed bins considered, a sample is shown in this table. For non-predominant patterns, considering all the non-predominant patterns within a traffic state, the bin probabilities for each vehicle classes are accounted. So based on this framework, moving further, in this paper, we have presented traffic state prediction using data collected from any location-based sensor. The data is like disaggregated travel time data. We don't know the vehicle classes associated with it. So based on this raw data, using our logistic regression model, we can predict the future traffic state using lagged traffic state. Moving further, we have developed a class-wise speed estimation framework in which a probabilistic framework is being adopted using 3 different assignment procedures: point estimate, expected value, and distribution preserving. And finally, ensemble voting algorithm has been chosen to identify the pattern for each traffic state. So I'm here presenting my state prediction result. We can see the consistent performance across most of the traffic state with the overall prediction accuracy of 70% and F1 score of 0.68. Proceeding further, for class-wise speed estimation approaches for all of the traffic states considered, I have considered the predominant patterns, non-predominant patterns, the associated bins. Using these, first, it's the point estimate approach where the pattern with highest probability has been chosen for the particular traffic state. Then in expected value rounding, the weighted average of all the probabilities are considered, and in distribution preserving allocation, it is the joint probability across all the bins. So this table shows for selected traffic states, the ensemble, based on ensemble voting, the final chosen pattern. Here I would like to explain the pattern in the chosen order, like 3-wheeler, 2-wheeler and cars. So pattern 1, 1, 2 denotes 3-wheeler in the first bin, 2-wheeler in second, and car in the bin 1 is 2-wheeler and 3-wheeler, and bin 2 is car. So emphasizing on the major key contributions of this work, it is class-wise inference from the raw data, that is disaggregated and class-agnostic travel time data, and unified modeling framework which explicitly captures the vehicle class heterogeneity by defining the traffic state as a class-wise variable rather than aggregated stream variable, and multi-method state identification, so considering point estimation, expected value and distribution preserving, and then dual level representation. So with this framework, we can have flow insights at a macro level, that is the state prediction, and then micro level vehicle class-wise behavior in the second part of the work. Towards the application end, this framework can be integrated into intelligent transportation system applications. Few of them are listed here, such as adaptive signal control, congestion pricing or demand management, traffic simulation and control evaluation, and traveler information system, which focuses on the vehicle class specific interventions. So our work demonstrates how raw traffic data can be transformed into meaningful and actionable mobility insights. And as we move toward an era of connected electric and autonomous vehicles, the traffic stream will become more multi-class in nature, and hence there is a need for this class-wise characterization framework and data-driven insights to plan for a smart and sustainable mobility system. Thank you.
Thank you. Any question, please, from the audience? Anybody? I think they are. Yeah, there is a question. They have a mic.
Sir.
Now, should we? Yeah, we can give the mic.
You mentioned that you have chosen Chennai, Surat, and Guwahati.
Yes, sir.
Can you please elaborate why these three cities were chosen?
Yes, sir. So regarding the data collection, the major focus is to observe the mixed traffic conditions observed in India. So first, for the characterization framework, I have used data from Chennai to define the traffic states. Then to proceed further to identify the prevalent and less frequent pattern, diverse data set from 3 Indian cities has been used to determine the most commonly observed patterns within this thing. So that's why other cities like Surat and Guwahati also used, which represent a similar urban context.
Yeah.
Sir, can I ask one question?
Go ahead.
Okay. So my name is Abi. I'm from CDAC. So you have mentioned a mixed traffic condition, but you have selected only 3 types of vehicles. Why? There are other vehicle categories are there that can contribute also this traffic.
Not able to hear. Can you?
So they are asking, you have only taken 3 vehicle classes while you're talking about mixed traffic, where other category of vehicles are also there. Why you didn't consider other type of vehicles?
Yes. So for the characterization framework, first we have considered 5 vehicle classes: 2-wheeler, 3-wheeler, car, LCV and heavy vehicles, and we came up with 50 traffic states in the order of free flow to congestion. And for this prediction framework, due to lack of data availability, I have considered only 3 vehicle classes: 2-wheeler, 3-wheeler and car, the key vehicle classes. But the same framework can be extended for more than 3 vehicle classes also. If we have diverse data set, the same framework can be applied for a more number of vehicle classes, if we get data from like LCV and heavy vehicles also.
One more question. Have you considered any peak hours or off-peak hours traffic?
Have you considered?
Peak versus off-peak data.
Yeah, for the prediction framework, like one-day data has been considered, and in state prediction model, I have used the logistic regression, which accounts for the traffic trend group prediction, and then only the states are predicted. So it is the temporal variation across 24 hours time setup is being accounted in the prediction algorithm.
Any other question?
Yeah, what is your, how do you plan to use it in the real world applications? Like, how does these things can be used in planning or some other exercises or transport planning or something, urban transport planning or something?
I didn't get, sir. Are you asking about?
How do you plan to, apply it in real world conditions? And maybe how can you improve urban transport planning?
Using this like class-wise behavior, we can move with the class-wise interventions such as dedicated lane for some vehicle classes or derouting of some vehicle classes, signal priority. So all class-wise interventions is the application potential of the present work. And ATIS also, where we have class-specific
I think
prediction, speed
I
prediction.
think we'll just have last two quick questions. You want to do the
So I mean, I was not clear about for you what is the traffic state that you're referring to and what is the class-wise classification you're referring to. Can you just explain it again?
Okay.
And you can just describe it. No need to go to the slides. Can you just describe it? You don't need to go to the slides.
So regarding the traffic state, I have, for the study, I have considered these 33 traffic states accounting for 3 vehicle classes. So each traffic state represents a band or spectrum of speed. Say for example, traffic state 1 represents a band 54 to 60 kilometer per hour speed, where all 3 vehicle classes are in that bin. State number 2 represents 48 to 60, 2 bins like that.
So within that, what is that you're referring as classes? I mean, you're trying to bin vehicles into different classes based on their speed.
For the characterization framework, it is like how many bins are occupied for each traffic state. There, not class, like vehicle class are mapped to the associated bin. In the next part, the class-wise speed estimation allocates vehicle classes to the respective bins.
So my question is, for real-world applications, do you need this level of disaggregated classification in any of the applications that you talked about, whether it is traffic signal optimization or any ITS application where class-wise data is useful, but this is too disaggregated. And also the CAV, the last slide that you showed. In CAVs, the behavior of connected autonomous vehicles will be guided differently, not really by this kind of data where the vehicles are manually driven and not CAVs. So I really don't think this can apply to those kind of applications.
Can you please clarify the question, sir?
I'm saying for real-world applications, this level of disaggregation of classes and state is not required. That's my whole point. This is too disaggregated finer. I mean, if you are introducing congestion charging, you won't really look at this level of disaggregation.
Yeah, actually, for the to apply this framework, we just need travel time data, like class agnostic. We don't need any class-wise information.
That's why. So you have to really think about really practical applications for this, disaggregated level of classification that you're doing. That's my humble point.
Yeah, I think I would agree. And finally, one small question. I think somewhere in the end, you have mentioned that your work can be useful for modal split assessment and long-term mobility strategy. I'm not able to understand how. What are you trying to say when you write in the paper?
Can you repeat?
You've written in the paper as a utility of the work that the research finding will be useful in mobility split assessment and long-term mobility strategies in Indian cities.
Yes.
Can you elaborate a little bit how your work can help us in, coming to mobility, mode choice, modal split assessment?
Yes, sir. ATIS is one such thing which I explained. In addition, in future mobility context, as mentioned, future traffic will be more of multi-class in nature, which is a mix of conventional vehicle, human-driven, electric vehicle. So this mix will exhibit diverse vehicle behaviors observed.
So I think what you're referring, I think I can slightly correct you. It's not called modal split. You're talking about traffic stream, actually, traffic composition.
Yes.
Your entire work is on traffic composition. So it's not modal split. I mean, that you should be slightly correct on that terminology. Okay? Yeah. Okay,
regarding modal split in ATS, we can have like departure time planner where we can decide like if I choose this mode, what will be my travel time, and if I choose the alternate mode, what will be the travel time.
I think that is too much of an extension of your work. It doesn't, in the current state, we don't know how it is going to get connected. So it's very futuristic, what you were referring to. Are you getting it? Okay, thank you. Thank you. Yeah, yeah.
Thank you.
Now, may I now request Ritam Samanta? Ritam, yeah. 10:30 se hai na? Has it started? I'll go after 5 minutes. Yeah, yeah. So who will coordinate here? You will coordinate then. Okay. So Ritam Samanta, along with Mayank Dubey, he's now presenting a paper on reconnecting urban spaces, a strategic approach to tramways through heritage route mapping, a case of Kolkata. Okay.
Yes, sir.
You can start and just maintain the time. Okay?
Yes,
Yeah,
definitely.
yeah.
So good morning, everyone. So I'll be discussing about my research paper, which is the reconnecting urban spaces, a strategic approach to tramways through heritage route mapping, a case of Kolkata. So along with me, so my co-author is Dr. Mayank Dubey, SPA Bhopal. So this is the overall structure of the presentation. This is the content. So I'll be concluding my presentation in 17 slides. So this is the overall structure. So starting with the background and the need of the topic. So basically, we all know that the tramway system is started in the year of 1873. In the first, it started in Kolkata. So after that, it was started in Bombay. And also after that, several cities in India started the tramway system. But current days, in all the cities are closed. Only currently it's operated on Kolkata only. But recently, in Kochi is also planning to reopen their LRTS system. So to explain the need of the topic, so I have shown the cost versus distance and the cost versus time graph. So it shows that to travel a 8 kilometer of stretch, so in till date, the tramway system is the more economical with the only rupees 7 total cost of the travel. So now coming to the research design. So I have formulated 3 research questions. So basically, this first one is what caused the decline of the tram in Kolkata. Second is what is the present role, and the third is what are the alternatives. Like, what should we do? We should close the tram routes, or we should operate on the new routes, or we should operate in a heritage routes like that. So the aim of the topic is to explore the opportunities of tramway systems in context of both sustainability and heritage considerations. To achieve the aim, so I have formulated 4 objectives. So one is that to identify the reasons behind why tramway system is deteriorating, and the second is that to examine the existing condition of the tramway system. And the third is to analyze the all attribute to conduct a gap analysis through the system which needs improvement. And the fourth one is like to propose a planning framework for the tramway system. So this is the overall methodology. So the methodology is segregated into 5 stages. So in each of the stages, so like how I am going to achieve each of the objectives. So this is elaborated in the methodology. So the first objective will be achieved through the literature study, like how is the tramway systems in the other world, other countries, and also in the history of the worldwide tramway systems. The second objective will be achieved through the primary surveys and through the secondary data collections. And the third objective will be through the data analysis, like the multi-criteria decision-making system. And the fourth is to propose a planning framework through heritage route mapping. And finally, the concluding with the future scope of the study. So the 3 research questions which I have shown. So this is I have tried to answer the questions like what caused the decline of the tram in Kolkata. So this is the overall factors like lack of infrastructures and introduction of bus services, and also when the starting of the metro routes, and some in the construction of flyovers. These are the main reasons why the tramway system is getting deteriorated in Kolkata. So the first route was closed in 1971, and after that, so in the last route, which is closed in 2020 due to the natural calamities and the cyclones. So currently, only 3 routes are currently operational with the route length of 20 kilometers only. And the second question is to what is the present role of tram in Kolkata? So if we see the tram line from the very first of the 1873 to till date, so we have seen that during 1969, so it was the peak time, like there was only a maximum of 37 routes were operated with the track length of 70 and 74 kilometers. And currently only approx 20 kilometers are currently operated. And also the daily riderships also decreased, like we can see that the year of 2008, so there was a 1.6 lakhs of passengers are there, but only in 2022, only 15,000 passengers are there. And also the income and expenditures of the WBTC, that is the operating of the tramway system, so their expenditure is 30 times of the income. So this is the current present role of tram in Kolkata. And the third question is what are the alternatives of tram in Kolkata? So to address this question, so I have answered through the primary surveys. So these are the total 132 responses have been collected, through which we can conclude that 66% of the residents have agreed to operate the tramway systems in other route, also the new route also. And also the approx 89% of the residents and the persons of agreed that the tram should not be closed in Kolkata. So this is the case study. So I have referred to one is a tram train system in Germany. So it is a Karlsruhe city and the Kassel. So it is basically where the tram system is meets with the regional high-speed railway system. So it basically helps to reduce the travel time of the city. And another is the bidirectional tram system in Poland. Is basically it can be utilized where the land parcel is less. So where also the enough space is not there for the tram loop. So we can take from these 2 papers. And so coming to the introduction of the study area, this is the Kolkata Metropolitan Corporation's study map. So this is my site area, and this is the total area is 205 square kilometer with the populations of 4.5 million as per the census 2011, and the projected populations for the 2021 is above 6 million. So to give the brief idea about the tramway lane, so the map represents the operated tram routes in currently operational in Kolkata. So also I have shown the metro network system, and also the routes are closed in Kolkata. So currently are 3 routes only operated in Kolkata. And so coming to the data analysis, so I have conducted the stakeholder interview and also expert interviews. So I have addressed the SWOT analysis through where I have taken the quotations of each of the experts to address the strength, weakness, and opportunity and threat of the tramway systems. So it shows that the strength is the sustainable transport system is still present in, and also weakness we can say the lack of governance, absence of city master plan. So it can be a weakness, and opportunity is the priority treatment and heritage route mapping. So we can through which we can revive the tramway systems. And the threat is the excessive cost of the electricity and the condition on the road. So now coming data analysis, so we have taken the 121 heritage sites, so which covers the historical sites, monuments, and the police stations, administrative offices, bazaars, school and colleges, cemetery. So all have been taken. So it's basically when we are consulting with the experts. So this is the feedback taken, and then utilize this thing. And also coming to the we have formulated 5 parameters, and which is segregated into further segregated into each of the 2 sub parameters. And so starting with the to give the ranking of the each parameter, so I have taken the grade relation analysis through which we have ranked all the parameters. And coming to the weightage distributions of each of the parameters and the sub-parameters. So like we have, this is the weightage given to each of the parameters, and further equal weightage is given to the sub-parameters. And again,
excuse me.
Yes.
Please try to conclude. We are running out of time.
Okay, sir. So this is the overall scenario. So I would like, this is the formula. And this is the overall calculation. So I have shown down 25 samples, how we're getting each of the heritage sites ranking. And this, further I have taken the two scenarios where the one is to take the only top 50 heritage sites, and the another one is to take the overall heritage sites. So, and also like the parameters have 8 parameters have considered, through which the best routes have been taken. And so in the comparison table, we can see like the 6 options have made. So out of that, 4 have been taken as the most preferable. So the map also represents the proposed tram routes, and also like the I've taken the 20 kilometers per hour the speed. So I've calculated the running time and the journey time with the proposed route. And finally, concluding with the recommendation and the planning framework. So like for the financial aspects, so the government funds and the global funds can be utilized to plan this, to use this thing. And also like the planning framework for Kolkata context, so CF Urbus model can, and also like the CTDs model can be taken. And also like coming to the technical aspects, so like bus rerouting, and also increase the parking charges, so like to smoothly operate the tramway system in Kolkata. And finally concluding with my research, like the way forward and the future scope, like we can extend these tramway systems outer the KMC area, like in also we can take the NKD, like Newton planning area boundary, and HMC boundary.
Thank you. Thank you. So now we are open for the questions. Do you have any questions from the public?
Hello. While looking for when you are proposing the scenario, have you looked at number of passengers that are going to onboard? Have you looked at the demand versus what you are supplying?
Yes, I have conducted the onboard surveys. So I have calculated the number of passengers actually using the tramway systems, and I've surveyed it at the terminals, and also like the onboard PT surveys to get the what are the origin and destinations of the people, and what is the trip purpose of the residents who are actually using the tramway systems.
So is there time also considered, like the comparison in time with trams or other modes of transport that would be used? So are people willing to shift to trams in terms of savings of times?
I have where I've showed the cost versus time and the distance graph. So I have considered the other modes of transports like suburban rail, EIPT, and in the same corridor where the tram is operational. So in that way, I've taken other modes of transport as well.
Okay.
Yeah. Thank you.
Just one question from my side.
Yes, sir.
What I want to say is that basically the whole premise, what you have given in this paper, it shows that basically the tramway in Calcutta have been, they are not popular for the reason of the governmental support. But question is that now MOHUA also was planning to propose LRT, which is essentially like tramway, and you have given the example of Germany. In Delhi, we have been trying very hard in Connaught Place area and Chandni Chowk area to popularize the tramway. The biggest problem is that unless until there is a policy decision where the tramway is given a priority over the vehicular traffic or a clear movement space, it will not work. So it's not a technical issue that you need a upfront, a beautiful looking tramway. The issue is that unless until there is a priority or there are certain pedestrian zones, no vehicular zone, or that there are certain zones where only the public transport like tramway is allowed, like in the inner Connaught Place circuit, it will not work. So means the whole premise is very, very biased, where you are thinking that probably the governmental support is not there in terms of the funding. That's why it has failed.
Yes, sir. This can be one of the reasons why it is.
Thank you, sir. Thank you.
Thank you. First of all, thank you very much for excellent presentation. I continue from the point made by the previous person who asked the question, and that is for trams are being considered all over, well, particularly in Asian countries, Asian cities, to see whether they can provide a sustainable type of public transport system in cities, especially dense, high-density cities. You see? And inevitably, they run across challenges, okay?
Yes.
And because of that, and some of the challenges I think are highlighted just now. But so my question to you would be, in the case of the Calcutta tram, okay, I saw on your slide from about 1996 or 1969 until 69. Now, the ridership dropped from what, 1.6 lakh down to 15,000 or something like that, right? Yeah.
Yes, sir.
Now my question to you is, yet the majority of the people in Calcutta say they love the tram. They want to keep it and all that, right? So my question to you would be, did you look at what were the reasons, what were the key reasons why the ridership dropped so much? Because, was it because the tram is not in the right position, it doesn't serve the right corridors, or it doesn't have priority like was mentioned just now? Did you look at that? And if you have, please share your
currently, the tram is operating on the mixed transit corridor. So this can be the one of the reasons, like where that speed is gradually degrading of the tramway systems. So if there can be provisions like to dedicate the routes of the tram. So if the speed is increased of the tram, so maybe the riderships and also the residents of the Kolkata may, again, the ridership may increase, like if we plan in that way. So this can be the, like, my input in your question.
My question was, what are the reasons why the ridership dropped? Was it competition from the other modes of transport, or was it because the tram wasn't in the correct position?
So one option is like maybe like there are other modes of transport is all available, like metro is also there. So
the buses, yeah, motor
buses is also there.
Okay.
But if we like revive the tram in the like connecting the two metro stations where the other modes are not operational, like only the IPDs are there, so we can think on that way, like we can operate the tram in that way, like not going on with the same corridor where the metros and buses are going on, so we can rethink and reorganize the routes also.
Thank you very much. Thank you.
Thank you.
Thank you, thank you. Any more questions?
Yeah, actually it was a very nice
Very
presentation.
quick, please, sir. Running
Yeah.
out of time.
Yeah, actually it was a very nice presentation, and practical application seems to be like you have planned for alternative routes, as tram was not successful in Kolkata, and you have suggested some alternate routes.
Yes, sir.
So what was the methodology for using, selecting these alternate routes? And if I want to extend this study to other modes of transport like metro, especially the planning for metro routes, so can you think about that thing also and propose something about it?
Talking about the metro routes and other, like the methodology you have mentioned, like for the alternative routes. So like if we plan to operate the tram as a only in the, if we just forget everything and only operate the tram as a freight, like in the night time also, so we can reduce the carbon emissions. So in that way we can think, and we can also like there will be alternative options for the tramway systems.
So what I'm saying, your study methodology, can it be extended to other modes of transport like Delhi, like metro system planning, and can you suggest some routes based on your study, which will be of practical applications for
Sir,
deciding?
As of now, like I'm exploring these things, so it can be utilized, that methodology, to the other modes of transport as well.
If you want to summarize the methodology for you selecting routes, but it will be in a summary form.
So,
Selecting routes.
Okay,
Kindly
sorry to cut you down. We are really rating. Okay, thank you.
thank you.
So we have our last presenter, 818 paper ID, Shiksha Singh, Mobility as a Service, Insight from Global Practices and Implication for Indian Cities. Yeah. Do we have Shiksha Singh? Singh, sorry. Yeah. Thank you.
So, hello everyone. I have a presentation on mobility as a service, insights from global practices and implications for Indian cities. And I've worked with my co-authors, Professor Ramesh Anbanandam and Professor Devdutt Parida. So first, we know what is mobility and what is service. So mobility, it's the ability and freedom to move, and the service an act for which we have to pay. So mobility as a service, it's a mobility to provide as a service. Like it integrates the travel planning, real-time information, ticketing and payment services. So it's a promising solution from the global north cities, which enhance the attractiveness of mobility, which particularly focus on the public transport in the collaboration of the private transport. So that there are three core dimensions of MaaS: the integration of multiple modes, the provision of seamless access through a unified platform, and the emergence of new business and governance models. So the major problems, like the India's transport demand is growing from 1980 to almost 8 times. The PM 2.5 means the high private vehicles are increasing. So it contributes to the PM 2.5. Out of 14 most polluted cities, 14 out of 15, they are from India. And the major cities ranked amongst the world's most congested cities are from India. So MaaS came into the picture. It optimizes the infrastructure use, reduces congestion, lowers emissions, and enhances the urban living. But it predominantly implemented in the global north cities. It is not feasible to directly implement the concept of global north to the global south cities, which is in India. So Indian cities have distinct features, have various types of organization and different types of governance and policies implications for different transport operators. So the research gaps came into the picture, lack of concept knowledge because we don't have full picture of the projects which implemented in the global north, and the limited information of frameworks which they implement to implement the MaaS. So the research questions: what are the defining characteristics of global MaaS initiatives, and how do Indian cities currently position themselves in relation to these characteristics? So the aim of the research is to synthesize existing knowledge on MaaS practices worldwide and assess their applicability to the Indian context. So there are three objectives. First, to identify the best practices through a scoping review methodology, and to analyze, the second is to analyze the cases to extract the key characteristics, and the third is to apply these characteristics to the case of the Bangalore in order to identify the context-specific barriers or opportunities. So the scoping review methodology is the type of the literature review. It's implemented for the broad, if we have broad topic and we have to synthesize more from the broad research. And it's mostly qualitative. So I simply searched string for the MaaS, mobility as a service and multimodal integration or mode integration. Then I got around overall, after the screening of the title and abstract and the full paper, I got 103 papers which are relevant to my study. So from this scoping review, we find the global MaaS projects. Then we analyze the data and find the characteristics of the mass projects. Then I took the case of Bangalore and compare it with the help of the comparative analysis and find the barriers and opportunities what we have and the key recommendations what we need to implement. So these are the 42 identified global practices of mass. This is just a table and a blank columns are shown. It's data not available for those projects. So this is the overall summary of the table. The first, mostly of the projects are operational. It's started with the pilot, but it's now in the future, means in the future of the relevant schemes, they are now operational. They are mostly integrated 5 to 10 number of modes. Then they means the projects mostly have the PPP model, public-private partnership, and they mostly use the smartphone apps for the user interface. And the project service provision is mostly all the types of informations or ticketing and payment. But the pilot projects have limited real-time information. They only integrate with ticketing and payment thing. So the project subscription model is mobility as a service and the pay-as-you-go, but mostly pay-as-you-go is used. Mobility package is mostly used with the additional package or additional perks for the service used. Then the payment mode is mostly e-pay or the smart card payment. And the level of integration of these projects means mostly are level LOI 3. So the analysis of mass projects is basically a regional imbalance. Only 3 projects are in Global South nowadays. Then the scale and type of the projects, large cities implement the operational projects, and it's in hybrid subscription, and they integrate around 8 to 11 modes, and it's come in the higher LOI, that's 3 or 4. Then the small cities which are having population less than 500K, they started with the pilot projects and integrate less number of modes to check the feasibility in their cities, then and use the pay-per-use models. So the national scale projects started means collaborating with use the model PPP, and dense areas have focus on public efficiency, while the sprawling ones started with the pilot project with limited features. So the governance and policy link, high-performing projects is basically which have added the addition of policy, operational, and have PPP model, and include the more number of modes and have the more LOI. So the integration insights, there are no link between the number of modes and the LOI. Some projects have more LOI, but less number of modes. So I didn't find any relation between the number of modes and the level of integration. It depends on the what type of services we are giving and how better we provide the services to the users. So the operational projects offer complete set of service provision. There are 5 set of service provision: real-time information, booking, ticketing, payment. So the pilot projects is basically of real-time missing the real-time information. That is because there is a gap in data sharing between the different transport operators. Technology and business models, the smartphones dominate. The subscription model is a mix of both pay-as-you-go and the mobility package. And the e-pay and the smart card are the most commonly used for the payment. So there are these 3 9 characteristics which I found from the global practices of mass. The first is range of modes, means the number of modes they are included and what type of public or private. Then the second is additional of policy, what policy they are integrating, like for the data sharing, for transport, act on transport services, and for the data quality. Then the project model, it's public initiative or private or PPP. Then the user interface, smartphone or web-based. Then the service provision, real-time trip planning, booking, ticketing, and payment. Then the subscription model, as pay-as-you-go or mobility package. Then payment system, level of integration. Level 1 is only information integration. Then 2 is booking and payment integration. 3rd is the integration of the service offer, means the bundling of the services. And the 4th is integration of societal goals. And the last is the additional perks. It's like the carbon credits, what we are saving by using the public transport, and what additional services they are providing. So I took the case of Bangalore, as Bangalore is facing the pollution and road congestions rapidly. And the public transport share is also decreasing from 42% in 2007 to 27% in 2011. And also the private vehicle ownership is rising, and mostly consists of two-wheelers. And the last mile connectivity, and reason is last mile connectivity and the weak multimodal integration. So I took the Bangalore case because they have some initiatives started. The first is the Tumuk app. It's only for the public transport, and it have the LOI of real-time information and ticketing. Then the Namayatri app, it's the open platform for the cabs and the autos, and they also it's only for private, for the informal modes, but they include as a new feature Nama Transit, which integrates metro also. So as we talking about what we have in Bangalore, it's a policy and institutional support. They are working on TOD 2022. It promotes the high-density mixed-use development along metro corridors to boost the public transport use. Then the BMLTA, it's a transport agency. It can work as an opportunity for the future, which integrates different modes or have some policies for the future. So the barriers and the opportunities. The first we were talking about the barriers. The first is fragmented institutional and digital environment, what we have. The lack of organized data sharing and collaboration mechanism. Third is limited inclusion of informal and semi-formal transport modes. And the fourth is the absence of governance protocol. Then the opportunities. The current technological infrastructure is good for the adoption of the mass. Institutional establishment of the BMLT agency. Then the alignment of current policy framework. And the fourth one is widespread use of smartphones, and we are digitally literate. So the recommendation, the first is institutional framework, formalize the mass under a PPA model with the BMLTA regulatory agency, so it can define the data sharing protocols. Then second is the pilot deployment. For future, we have to try with the pilots in the most means the high demand corridors, including the metros and the buses and auto rickshaws. And we can also provide incentives with in the pilot. Then the third is the structured contracts. We really need some informal structured contracts for the semi-informal and informal modes of the transport. So the conclusion, mass is a promising concept, and the lack of concept knowledge is the research gap. So by using the scoping review, you find the 42 global projects, and there are the 9 key characteristics which we found. Then the mass project is evolving in nature. It doesn't mean that we started with the pilot, we will stay in the pilot. We will have to upgrade it operational, and we have to provide more services and the additional perks so that the users can use it and adopt the public transport more. And its PPP model is showing the positive results or the positive performing systems. Then but it requires a supportive governance environment so that data sharing, regulatory consistency, and a formal policy which a formal policy can provide. So success of MAS is rely not on technology, but on the governance structure, institutional arrangement, and policy, which we can provide by giving the bundling services. So these are the references. Thank you.
Okay, Siksha. Any question, please? I presume it was more of a literature kind of work, na? I came late.
Okay, so I will show.
No, I'm just trying to, this is largely, Acha, you did a case study?
Yes.
Okay. Did you also try to compare, there have been some research efforts in mass, maybe there was a study done by CEPT, I'm sure you are aware of the study?
I aware with the study of SPA Delhi.
SPA Delhi, yes, we did some work, and CEPT has done a research study on mobility as a service. Did you incorporate that in your work?
Please, what kind of work they did? So maybe I can.
No, it is there on the probably in their website, but I'm aware it was a funded work they carried out. So I think you should, as a researcher, probably incorporate whatever has been done, okay, and then highlight kind of what has been your contribution to it, isn't it? Okay, I think if there are no questions, we can close the session. Thank you.
Sir, he's having some questions.
Yeah. Are there any questions?
Yes.
Yeah, please. Yeah.
Good morning.
Yeah.
My question is that you've tried to look at the possibility or kind of the future of MAS, but have you seen it? What are the limiting factors, especially of MAS in India, with respect to data sharing protocols, and then especially fair integration, and how that's probably the most difficult part that we all face. Right cancellations, how do you, refund the right cancellation to people? What is the mechanism for distributing this fair revenue? Because we've got multiple stakeholders. It can be private, it can be government. So have you looked at what are the limiting factors of MAS, which is probably we are all more interested in, because we are all trying to establish it, but yeah.
Right now, basically, I am just covering the literature part, and just by comparing the literature, I found out the barriers, which I showed in the last, second last slide. So my field work is little going on. So hopefully, I can work on that and find the limiting barriers for MAS in India.
So it's literally only a literature review paper that you've not
Yeah,
gone
it's
beyond.
based on literature and on the comparing analysis of the case study of Bangalore, not with the, till now I didn't complete my field survey. Okay.
So thank you. I think we should applause to her.
Thank you, sir, for conducting this session. And I would like to request Mr. Deepak Kumar to present the memento to the Honorable Chairperson. Please come on the... Sir, if you can kindly come on the stage.